They plan was to knock me out the top of the game, but I overstand they truth is all lame. I hold cannons that shoot balls of flame right in they fat mouth, then I carve my name.
Okay, so now for the fourth and final problem for this practice problems video, we have a truck with 32-inch diameter wheels is traveling at 60 miles per hour. Find the angular speed of the wheels in radians per minute. How many revolutions per minute do the wheels make? So let's write down the information that we do have. So we have, let's say this is one of the wheels, right? And we know the diameter. So D is equal to 32 inches, which means half of that, which gives us our radius, is equal to 16 inches. Okay, so here's our R, 16 inches. And it says it's traveling at 60 miles per hour. And that gives us the velocity, the linear velocity, right? So V is equal to 60 miles per hour. Okay? And it says to find the angular speed, so we want to figure out what is omega in radians per minute. That's what we really want, okay? And then it asks another question as well. So the thing is, to relate linear velocity and angular velocity, we have this useful formula. V is equal to R times omega. So if we want to find omega by itself, we just divide by R on both sides. So we get omega is equal to V over R. So all we have to do is just plug that in. So we have omega is equal to V, so that would be 60 miles per hour, over R, which is 16 inches, right? So this is the same thing as saying 60 miles per 1 hour, and then times 1 over 16 inches, right? So now we have this, and if you were to multiply that out, then you'd get something miles over hours inches. Wait, what? What's going on here? So the thing is, what we have to do now is just find, somehow convert the units part. That's all we need to do, okay? So first, before we do that, we can just kind of simplify by dividing by 4, just to make the numbers seem a little bit easier. So we'll actually get something like this. Omega is equal to 15 miles per 1 hour, so 1 hour, okay? And then 1 over 4 inches. Okay, so the thing is we have to convert all of the units here. So in order, this is kind of funny and strange, but anyways, 1 mile, because we want miles on the bottom to cancel out here. 1 mile is equivalent to saying 63,360 inches. Okay? And it's beyond me why this problem even wants us to convert all of these things. But anyways, so then we also want to convert, now that we've canceled all those out, we want to convert hours into minutes, right? Because we got radians, because now we have no unit of length or distance going on. So we have radians, now we want minutes on the bottom. So now all we have to do is say 1 hour is equivalent to saying 60 minutes. And then we'll be good on our units, okay? And now I can just multiply out the numbers and get our final answer, okay? So let's do that. Let's finish this off on the next slide. So we have something like this. Omega, which tells us our angular velocity, is equal to 15. I mean, now we have no units on the top, so we have just this other number that came from the inch conversion, mile to inch conversion. And then on the bottom, we have 4 times a 60 going on, and we have minutes on the bottom. We actually have radians up here, but it's not really a unit. Anyways, that whole thing. So now we can cancel those out, and we get 1 over 4. So this is equal to 63,360 over 16 radians per minute. And if you were to divide this, and it actually does divide evenly, which is kind of surprising, 3,960 would be our angular velocity in radians per minute. Okay, so that concludes our practice problems video for the section on angles. I hope that helps, and good luck on your homework.
Oh, 56, nigga, shut the fuck up. Fuck that nigga, run that back. Money.
Run that back, man.
What?
I gotta get out, man. You gotta run that back.
Run it back? All right, run it back.